Now let's check out the actual content of this course. Remember that this course is mainly practice problems, so if you have any kind of doubt or you have no clue on what we are doing, ensure to check out the Mass Balance Fundamentals course. In the meantime, let's check out the content. So here we go. We have 6 main sections: the introduction section, mass balance basics, mass balance in single phase, mass balance in multiple phase, transient state, mass balances, and finally the closure. Very similar to the Mass Balance Fundamentals course. This is, of course, with the intent to make it easier to check out from the theoretical course and the practice problem course. Now, of course, we get started with the introduction, which is essentially all the basics of the course, how it works, resources, the main books, check out the ebook, and so on. Now, then we continue with the mass balance basics. Every single section will have their unique update video telling about the main section. This is a general overview, but if you want to get more into the specifics, go and check this out. And as you can see, these are all practice problems based from the Richard Felder book, Elementary Principles of Chemical Process. And as you can see, there are a lot of problems right here. You can see different type of industries. We're talking about food industry, drying air, flow of carbon dioxide in a pipeline, different unit operations. We have the scrubber, we have bioprocesses, we have crystallization, drug extraction, and of course we can find also the main topics. This is something quite worth checking out. If we are looking out for multiple units, you can find it here. And as you can see, most of the time you can encounter the type of problems that we are trying to solve. For instance, combustion. If you want to check out a bypass process, you can find it here. If you want to check out a recycle process, you can do it here. If you want to verify for yourself a purge process, you can do it right here in section number 2. So as you can see, you will find a lot of practice problems depending on the topic that you want to search. Now, the second main block will be single phase. As the name implies, we're going to be working with a single phase, typically either liquid, solid, and of course gases. We talk about ideal gases, but also real gases, how to model those, why are these important to model in the industry, of course, but more importantly, applications to those type of industries. For instance, we're talking about hydrogenation using ideal gas. We're talking about the production of sulfuric acid with ideal gases in equilibrium. We're also talking about the production of methanol using real gases. We have the C compressibility factor for real gas applications. We also use K rules, very important for those real gas applications of mixture of gases, and so on. Then we continue to the third block, which is multiple phase mass balance. As you can see, we're talking a lot on the interaction between liquid vapor, liquid, and solid gas. We talk about vapor pressure. We talk about also Antoine equation, Raoult's law. We may be talking about Henry's law. We also talk about Cox diagrams. We also talk about the different type of diagrams. We have pressure and composition diagrams. We have temperature versus composition diagrams. But also we have these solvent-solvent interaction diagrams. We're talking about liquid-liquid extraction or properly liquid-liquid equilibrium. We have problems in here. And of course, if you're into transient or unsteady state balances, you will find this block right here. We have very simple problems such as the phosphoric acid tank, but then we get a little bit more complicated. We have the batch reactor analysis. We have many applications in biology and biotech. For instance, Michaelis-Menten enzyme reaction in unsteady state. And of course, we end up with a closure, a quick review on what topics we cover, and more importantly, what we learned on problem-solving material balances.